Okay, hey Carter, this is the last section that we're going to do, or the last section that we have to do, which is 5.7. We bumped back from like 5.9 where we did indefinite integrals and all that stuff. And this has to do with like the relationship between velocity, acceleration, all of the things, right? So we'll go over that. And then there's just some like real life story problems that we have that we're going to do in this section. So here we go. All right, let's talk about when I say like a position function. Do you know what I'm talking about? Position function is usually like the height that it's at, right? Position or height function, right? So like the height function tells you how tall it is, and a lot of times it ends up being like a quadratic function. I'll move that over a little bit. So the height function might be like s of t equals, I don't know, let's say t squared negative t squared plus 10. I have no idea, right? So what this is going to do is this is going to be a parabola up at 10 and going like this, right? Okay, so basically we ignore this side of it, right, because we're only looking at time being the positive x-axis, so it's doing one of those, right? Okay, then, okay, so let's say I have that going on there. I'm going to do this. I'm going to do this. Let's change this a little bit. I'm going to put negative 16 t squared plus 100, okay? Because that's more realistic. Have you guys ever seen 16 before as your whatever number? You know what I'm talking about? 16 is like acceleration due to gravity, but in feet per second, right? You've heard like 9.8 meters per second squared, all that stuff, right? Okay. Feet would be like 16, okay? Actually, it's 32 is acceleration, but like 16 would be the velocity, all that stuff. Okay, so 100 is my starting height, so 100 would be up here, okay? So that's the position function. Then, if I want to know the velocity at a given time, I take this function and I do the derivative. So v of t is going to be the derivative of the position function, so like s prime of t, which would be negative 32 t, right? The 100 drops off and it'd be negative 32 t. So I could find out what my velocity is. And so like at 0 seconds, right? Like when I'm first being dropped from this height, right? I'm going 32 feet per second toward the earth. Negative velocity means you're falling, right? Okay, so let's say like 2 seconds into my travels, I'm going 64 meters per second, or feet per second, I guess is what we're in. We're going 64 feet per second toward the earth, right? That's what my velocity is. And I keep going faster and faster and faster the longer I've been falling, because you start to accelerate, right? Does that make sense? This is the equation for velocity, like my initial velocity, okay? Then we cap off at acceleration, okay? And acceleration, if I do that, I'm going to just call it a of t, and it is the first derivative of the velocity or the second derivative of the position function, right? Does that make sense, right? So if I take the derivative of this guy, it is negative 32, right? And then my variable is gone, which is kind of interesting because the way that this works is that no matter where you're at, whether I've been falling for 1 second, 7 seconds, 33 seconds, which is probably a pretty tall height because, I mean, usually you've hit the ground after 33 seconds. But no matter what, you're going to be falling or accelerating at a rate of 32 feet per second squared. Like each second, you're going to be accelerating that many feet per second. Okay, so 32 is your constant acceleration. You're accelerating at a constant rate. Your velocity will not stay constant, and your height will not stay constant, but your acceleration due to gravity will stay constant. You will start accelerating faster at 32 feet per second squared. Make sense? Yes, this is how this works. Okay, going back the other direction, if they give you acceleration, you're going to take the antiderivative to get back here. You're going to take the antiderivative to get back there, right? And so that's essentially what we're doing. They're also going to talk about like displacement versus distance traveled, okay? So maybe we'll get to that. Okay, so let's talk about this right here. The position function right here, this is the position, and the antiderivative of position, or the antiderivative of velocity gives you the position function, okay? The antiderivative acceleration gives you velocity. Makes sense? So you do it like whatever. Okay, let's do an example. Suppose that a particle moves with the velocity. So they're giving me the velocity. And it is cosine of pi t. And that's what my velocity is. Whatever. Okay. Assuming that the particle has a coordinate of 4 at a time of 0, find its position function. So we're going from velocity to the position function, which is s, right? So we have to take the antiderivative. All right, we're taking the antiderivative of cosine of pi t. Now don't get confused. These are not your limits of integration. I'll tell you what those are here in a second. But I have this and I have dt. Okay, we have to find the antiderivative. Ugh. Okay. How do I find the antiderivative of cosine of pi t?
Substitution.
Yeah, we have to use substitution because that pi is in there. So u would be pi, right? Pi t, I guess I should say, pi t. And then du is the derivative of pi t. What's the derivative of pi t? Pi dx, right? Or dt, I guess I should say. Pi dt, okay? Because the t will go away, so pi is just your number out in front. He will be left over. Okay, now when we go to start substituting, here's my integral symbol. He gets left, right? This will be cosine of what? U, right? This guy is cosine of u. He's been replaced. But now I need to replace dt. dt is 1 over pi du, right? That's what he looks like. Kind of gross. All right, now we have to do the antiderivative. What's the antiderivative of cosine? Is it negative sine? The derivative of sine is cosine, so the antiderivative of cosine is positive sine. So sine of u, and u is actually not u is actually pi t. So I'm going to plug that back in there. I'm going to use parentheses. And then we have plus c. Okay, because we're not doing limits. We're not plugging any limits in. This is my function. All right, now, what do we use the s and the t for? To find c, right? So this is the equation of s. Let me use a different color. S is equal to that. We plug those in and we use that to find c. Okay, for the exact position function. So s is, what did they say, 4? S is 4 at a time of 0. I'm going to plug 0 in. Okay?
Check and then cash.
Oh, perfect. Okay. Oh, you had enough? Mm-hmm. Oh, nice. Okay, cool. Perfect. Okay, that makes it nice. And then the rest of that can just go to Michelle. And whatever Michelle already has, it's yours. You don't need to give it to me or put it in Fab Lab. Does that make sense? Like, it's all your stuff. Okay, perfect. Thank you. That works out really good. All right. Okay, let's do this first. Sine of pi times 0. Pi times 0 is just 0, yeah? Okay, what is sine of 0? 0 is over here, right? That would be the coordinate 1, 0, and sine is the y coordinate, so you're right. It is 0. Okay, 1 over pi times 0 is just 0, so c is 4. C is 4, right? C is equal to 4. Okay, so I know that s is equal to 1 over pi sine of pi t plus 4. And that's the position function, okay? They might instead call it s of t instead of just calling it s, whatever. But that's my position function. That's like where I'm traveling at. Or that's like the height of where I'm located at, right? Okay? Something of that nature. Good? Make sense? Ish? All right, we've done all this stuff before, I feel like. Okay, let's talk displacement now. Okay, displacement. Oh, how do I do this? If we're talking about like distance traveled, okay? Let's think about this. Let's say the distance that I'm traveling. Let's say like here is a house. And let's say here is a house and they are 10 miles apart, right? And I go here and I come back. Okay? My displacement is 0, right? But what's my distance? My distance would be 20, right? Okay, so the displacement is calculated, like that's the total, like that's like from where I was, like going, coming back, whatever, right? Okay, let's do another example. Let's say I have a house here, and I have a house here, and I travel here, which is 10 miles, and then I have travel back to 6 miles, right? What's my displacement? I travel back 6 miles. So this distance is 6 miles. What's my displacement? 4, right? I'm like 4 units positive from where I was before. That's my displacement, right? But what's my total distance? 16, right? Okay. Now maybe I started at this house and I went here and then I turned around and I went back here, right? Okay. So let's say this is 10 miles and this is 27 miles, right? So if that's the case, I stopped at a house here. What's my displacement? It would be negative because I'm to the left of where I was before, right? It would be negative 17, right? But my total distance is 37, right? Okay, so displacement is calculated by doing just the antiderivative of the velocity, right? Yeah, the antiderivative of the velocity, and then you're plugging in the numbers where you're starting, where you're ending. So it's basically like finding the position function, right? So it's finding the position function and then you're plugging your numbers in. So it's like S of t, and then you're plugging in your starting and ending numbers right here. Whatever, I'll call it A and B. A and B, you're plugging in those numbers. And that, when you subtract it, will give you your displacement. Your displacement. Now this one, the distance traveled is going to be the absolute value, okay? And we know by doing absolute value that you've got to like do it in pieces, right? So when we did absolute value, we had like that V thing going on, right? Okay, and we had to separate it into 2 functions. So we had to figure out what this guy was, and then we had to figure out what this guy was and add them together, right? So when we do absolute value, when we do actual distance traveled, we got to look at them as 2 parts, right? Distance travel, I've got to look at this part and this part together, versus displacement, I combine them together and then or I subtract them, right? And then it's going to be like that, okay? All right, so let's do example 2. Suppose a particle is moving on a coordinate line, so its velocity at time t is this. Now, I was looking at this problem just a minute ago, and I'm a little bit confused, so help me make sense of this as a story problem. If this is my velocity, okay, here is saying my velocity is 0, because I haven't yet let go of it, right, or whatever, but then my velocity is negative. And my velocity is negative until I get to here, which is at 2 seconds. And then my velocity becomes positive.
So you're going backwards?
So here's what I'm thinking, and see if this makes sense to you. Your velocity is negative, right? This is the equation for velocity. This isn't the position function. My particle's not going underground or whatever. This is the velocity, right? Your velocity is negative if it's falling toward the earth, right? So I'm thinking that what's happening is, like, think of this as a bouncy ball, right? Like, it's coming down, like the velocity is negative because it's coming down. It's hitting the ground, and then all of a sudden my velocity is positive again, which means it's bouncing back up. So this point right here is where it hits the ground. Would that make sense? The only thing I can't make sense of is, like, my velocity here is 0, and then it's going really fast negative velocity, and then it's slowing down. You know? So, like, it's going faster. It's going the fastest right here, instead of going for the fastest one before it hits the ground. So I'm confused. And maybe that's why they gave it to us like this, is this isn't meant to be a story problem, but I'm trying to make it into a story problem and make it make sense. So it's going the fastest right here, right? The fastest is -1, right? And then it starts to slow down again right before it hits the ground. And then it starts to go, like, speed up, which doesn't make any sense because it should slow down if it's hitting the ground, right? Hits the ground, the bouncy ball should start to slow down as it hits the ground, right? The velocity shouldn't increase as soon as it hits the ground. Maybe this wasn't meant to be a story problem, whatever. Okay, so let's just do the thing. All right, find the displacement from 0 to 3 seconds. Okay, so we're just trying to find, like, the distance that this thing has traveled. Not distance, displacement. So, like, where he's at. Okay, he's going negative, then he's going positive. So, like, basically subtracting those two. So to do A, we're just doing from 0 to 3, we're doing t squared minus 2t. And this is dt. So there's that. Okay? I'm just finding the antiderivative. Just trying to figure out what's happening, okay? Because if he is in fact, like, a bouncy ball, which is what this is doing. He's starting here, he's coming down, and then he's going back up again. Like my displacement is only going to be this right here, right? It's not going to cover this guy versus my distance covered is going to be all of it, right? Yeah. Like if this is my velocity, this is what my position function should be doing. It's having a negative velocity, then it's coming back up. So it's like going down, coming back up. This is what, so we're finding this displacement right here. All right, so all we're doing is finding the antiderivative of this function right here. We've got 1/3 t cubed minus, what's the antiderivative of 2t? T squared, right? The 2's cancel, okay? And we're going from 0 to 3, so I'm going to plug 3 in first. 1/3 times 3 cubed minus 3 squared. And then when I plug in 0, it is 0. Interesting. So my displacement, 3 cubed is 27, 1/3 of 27 is 9, minus 9 is 0. So my displacement is 0. So we've got something like this thing happening, right? Make sense? Like that's basically what's happening. Okay, now we've got to figure out so my displacement is 0, meaning I'm starting and ending at the same spot. But the distance traveled from 0 to 3 pi is going to, or it's from 0 to 3 seconds, is 0 to 3, but the absolute value of, what is my function? T squared minus 2t.
It just says.
Okay, dt. Right? So we have to do the absolute value, which means we have to add them together, right? Okay, yeah?
Oh.
Okay, so how do I do this if this is an absolute value?
You divide it where it's negative and positive.
Yeah. Right. So, you remember before where we would set like this guy equal to 0? T squared minus 2t. I got to figure out where he hits 0 at, right? But, problem with this, if I break this guy down, I have t times t minus 2, right? Yeah? So he's going to hit 0 at 0, and he's going to hit 0 at 2. Does that make sense? Yeah? So I could potentially have like 3 chunks here, but we're starting at 0 anyway, right?
Yeah.
Okay, so I need to separate this guy into 2 chunks, going from 0 to 2, and then doing something else from 2 to 3. Yeah? Okay, now I've got to figure out which one of these do I do t squared minus 2t, and which one of these do I do negative t squared plus 2t.
The one we altered. Would that be the one we use the negative?
Okay, if I think about what t squared minus 2t looks like, okay, he's hitting at 0, he's hitting at 2, he's doing one of these, right? Yeah? So in order to make, like which one is he doing right here? And which one is he doing right here?
One.
He's negative below here, right? Like from 0 to 2, he's negative. So I think I want to do this guy. So that it actually, like what this guy's going to do is it's going to flip him up here. So it changes that area and it makes it a positive area instead of a negative area. Does that make sense? Yeah, from 0 to 2. Instead of it being below, it's like we've changed the function from doing one of these to now doing this. And it's going to give me this as a positive area and this is a positive area, rather than the 2 canceling each other out. Okay, so now I forgot what I said. Okay, so this first one, we're doing negative t squared plus 2t dt. And we're adding to that the positive t squared minus 2t dt. Do we see how this works? Because this is going to give me that as a positive area instead of a negative area. Okay? Okay, so just slightly changes things. What's the antiderivative of this guy? Negative 1/3 t cubed plus t squared from 0 to 2. Okay, should we just go ahead and plug that in? Okay. We know, I'll plug in 2. That's what we get. When we plug in 0, we get 0, right? So this guy, 2 cubed is 8. Let me go in a different color. So this is negative 8/3 plus 4, which is 12/3. Yep, I like it. Which is 4/3. So that means like this little bump right here, I have gone a distance of 4/3, right? Okay. Now this guy, if I do him, t squared is 1/3 t cubed minus t squared, right? Okay, but we're going from 2 to 3. So I'm going to plug 3 in. 1/3 times 3 squared, or 3 cubed, minus 3 squared.
Yeah.
What?
We did it last time, right? Equals 0.
But now you're plugging in 3, or 2 though.
Yeah.
Oh, this? Yes, this ends up being 0. You're right. 0 right here, okay? Minus, now we got to get, like, we got to plug in 2, right? We got to plug in our bottom number, which is 2. I have a theory of how this is going to work. Minus 2 squared, right? It should be 4/3, right? It should be negative 4/3, right? This should be negative 4/3, but then I've got this negative out here, which is positive 4/3. And that should be right, because before, okay, before what was happening was we were doing displacement, right? And displacement is taking into consideration this and this. And this was negative 4/3 and this was positive 4/3 to cancel out to have a displacement of 0, right? Now they're making this a positive 4/3 and a positive 4/3. So we have what, 8/3? Which is 2 2/3. So 2 2/3 miles rather than traveling 0 miles. My distance was 2 2/3, but my displacement was 0. I'm getting back to the beginning. Does that make sense?
Wait,
Kinda
how
weird
is the
stuff.
Displacement 0 again?
Displacement's 0, meaning that I started and ended at the same spot. So like I'm going here, and they're saying this is 4/3.
The function right there is a velocity function. You actually.
Yes, yes. This is not the position. This is the velocity.
What is the velocity function?
What?
That is a velocity.
This guy that they gave me right here was the function of velocity. Yeah. So we're not talking about like the position. Like we're not talking about like the balls going underground, whatever, right? So this is negative 4/3 as an area. This is positive 4/3 as an area, right? And so when I do that, like the displacement ends up canceling out to be 0. Versus if I do the absolute value, it takes this little hump and it moves him up. So now he's a positive 4/3. And this is a positive 4/3, which is going to give me a distance of 8/3. So I've traveled a total of 8/3. So like if I look at this like linearly, I'm starting here at this house, I'm going 4/3 this way, and I'm going 4/3 back this way. My displacement is 0, but my distance is 8/3.
So the length of the line of the position function is equal to the area of the parent.
Yes, exactly. So yes, the distance that you've traveled is the area underneath of the velocity function, right? The area under here gives you the distance. Weird. Area is like represented as distance. That's the distance I've traveled. Weird stuff. Okay? All right, so if we look at this, like this is kind of a good like depiction of what's happening here. We're talking about displacement, okay? So this is my velocity function, right? But we just said that the area underneath of that tells me the distance that I've traveled. The area underneath of a velocity curve tells me the distance I've gone in that direction, right? So in this case, if I'm talking about displacement, this is positive area, this is negative area, this is positive area, right? I would just take the A1 minus the A2 plus the A3, and that would give me my displacement. I don't know. That might be, do you think he's more positive or more negative?
More positive.
I think he's slightly more positive. So we would end up like
Teachers,
potentially
if you still
doing
have
one of
down
these.
slips to turn in, please let
Right?
the office know at
Like
this
that's what would
time.
end up happening,
Again, a
right?
reminder, juniors, there will be a prom meeting during lunch today in Mrs. Comacher's room.
Versus the distance traveled, I've got to take this guy and turn around and make him positive, right? So we would add the A2 instead, okay? So by doing this, this looks a little weird. By doing this, what happens is we have this guy then gets flipped when we do the absolute value, and he does one of those, right? So it's adding these three areas together rather than taking into consideration the negative. Weird. This is like really advanced stuff, folks. Okay. What time do we get out of here?
38, I think.
We are on 38.
Oh,
Friday?
Did you look at the time?
Oh yeah, it is 38. Okay, all right, so we'll stop. Goodbye, Carter.
Bye, Carl.